So let's wait no more. Let's get started. Again, for those who joined us a bit later, my name is Dmitry, and today we will speak about inventory optimization. Uh, we have several topics to talk about. So we start with the general idea of inventory optimization. Then we will speak about the common approaches uh, to this problem. And then our most important and biggest topic would be simulation-based inventory optimization. And at the end, we will have a question and answers session, but please don't hesitate to ask any questions if you will have some problems during the webinar itself, because I have my colleague, Andrei, who will be supporting me and answering your questions through the whole duration of the webinar. Okay, inventory optimization challenges. To talk about challenges, first we need to understand what is inventory. And I think everyone knows that inventory or stock is just something we hold in our storage in order to resell or to use as a production material. And it is very important to understand that stocks are evil, because we can get no profit until they are sold. We need to pay a lot to handle them, like possession costs, storage area handling, and so on. And a lot of money are frozen in this inventory, and we cannot use them until we sell it. On the other hand, stocks are really good because we actually need them to provide a required service level for our customers or production. And for inventory optimization, the main objective is to find the balance between good and evil. Stocks are several kinds, and for example, operational stocks are required to keep our production going on. We need to hold some raw materials, to hold some spare parts, and so on. Also, there are some stocks which are caused by financial saves. For example, if we want to send only fully loaded trucks, we need to hold these extra items we transporting. Or on the other hand, if our suppliers have different conditions for different batch sizes, we can order more than we actually need at the moment, so on. Another kind of stock is demand-driven stock. Well, it's actually the most interesting and important one because it's really hard to control. It carries some stochastics inside, and also there are seasonality, there are some risks we want to mitigate, and many other reasons which will cause us to have a stock on hand. And there are kinds of different stocks, like when we want to speculate against price changes. For example, if we are going to sell gas or oil, we want to have some stock for our specific inventory policies and some others. And during our webinar, mostly we will talk about demand-driven stock, because again, it's very unpredictable, very hard to optimize, and probably the biggest stock to carry about. So let's talk about how demand could affect our stocks or our inventory. Let's consider a very, very simple supply chain. We have a single customer which order every day at 10 units of our product. And supply for our distribution center takes 4 days. So we need an inventory policy, something like this, with a reordering point of 40 units and the order size, for example, 80 units, because, well, it's full track load. And you can see on the right side what will be the demand chart and how our actual inventory will behave. So at 40, we send an order upstream to our supplier. Then during this supply time, we drop to 0, and then we get replenishment. And it seems good, seems perfect. But in real life, we never will have a perfect customer which order exactly 10 units every day. So in real life, this customer would probably order 15 units at one day, 5 units at another day, and so on. So demand may look like this. And for this customer, we cannot use our perfect inventory policy anymore because, well, we'll be out of stock sometime and our customer won't be happy. So in this case, we need some extra stock or safety stock in order to keep the service level up. Another reason is when our supply time isn't fixed. So usually you have a contract which says that your supplier should bring you your product from 2 to 5 days. In this case, we also will have stockouts until we carry some extra stock. Moreover, these two points could be combined, and in this case, you may see that our stockouts are actually quite big. So with reordering point of 40, we also need about 40 additional units in order to provide a good service level. So what can we do about it? We can use several approaches to optimize our inventory. Actually, there are a lot of them. So many companies use just a very simple approach. They specify the time frame for which we need to have enough stock to make any operation going, like finished goods, shipping, production, or whatsoever. And it actually can work quite well, but the costs will be, well, not very pleasant to see it. And more complicated approach is analytical, when you use mathematics, statistics, formulas, and of course Excel to calculate the required stocks, considering demand forecast, your previous history, and your contracted conditions with your supplier. Another approach is best practices or experience. Just take what is working now and use it again. It's good when you will have a new product which you need to add to your supply chain, or if you're expanding your company to another market. In other cases, it works as well. And another good option is just to go to some consulting company. You all probably know some of them, and just say, I need some inventory optimization, I need to save some money, and they will do all of it for you, probably using one of these three methods. So let's consider this one, because it carries some pretty interesting mathematics underground. Well, actually, here you can see a formula, a simple formula which can guarantee you a certain service level. This formula is used to calculate safety stock. I won't dive deep into the meaning of this formula. It just operates with some mean lead times, mean demands, and so on. And you can easily put it into Excel file and find out that for our previous example with a single customer with normally distributed demand and with fixed supply time, we need a safety stock equal to 13 units. So very easy, very handy to use. But let's consider this case, when our supply time is from 2 to 5 days, but we don't know the actual distribution parameters. Is it normal? Is it uniform? Is it any other way around? We cannot say. So basically, we cannot use this formula at this point. Of course, we can approximate, but it also carries some additional problems with it. So here we go to some problems which are caused by this kind of analytical approach to a safety stock estimation. In order to make it work, we need to have our demand and supply time distributed normally. You can see a normal distribution chart just below, and probably you already may see some problems. For example, it is not limited from the bottom or from the top, and that's not the real case, because in reality, well, our supply time and demand cannot be negative, that's for sure. They're probably also limited at the top. And in order to use such formulas, we need to actually calculate the policy parameter, distribution parameters from our history, from our forecast. And again, in reality, this distribution, this demand or supply time could not be like normal distribution at all. Another issue that for such approach, we need all our values to be independent, which could be true, but not always. For example, if you have several customers, certain peaks with the order size could be caused by the same reason. For example, for a rainy season, you probably need some more coats, and for a really warm summer, you probably need some more cold drinks. So in reality, again, demand and maybe supply time as well are not independent. If we have some seasonality in our supply chain, we need to recalculate this safety stock value for each season which has its own supply times or demand patterns. And probably one of the hardest topics for this analytical approach is a multi-tier supply chain. So, for example, in a case when there is more than just a supplier, distribution center, and customer, when you have factories, intermediate DCs, and so on, you could try to use this approach, but you will use this approach for each tier independently. So you take the first echelon, calculate safety stock values for the first tier DCs, then you go upwards, you propagate demand, you calculate supply time, and so on. And it could work, but actually there is no guarantee because, well, you considering your echelons independent, which is not true. Sorry. And some more thoughts about this analytical approach. We cannot put into this formula some specific supply chain behavior. So, for example, if you have returns, if you have a processing time which based on order size, if you're using not standard inventory policies, and you have additional sources of stochastics, for example, in a production time, it's really hard or almost impossible to consider it in this formula. You may play around with it, you may change it, but it's quickly getting very complicated and you need a really good mathematician to handle it. But there is another way, the simulation-based inventory optimization. Let's talk a bit about what actually dynamic simulation modeling is. Instead of formulas, values, and so on, we consider the set of objects and logical rules. So, for example, if we have a customer, distribution center, a factory, and a supplier, we can just describe the behavior of each object. Like for a customer, we can say that it places order for a certain amount several days a week. Then you describe the behavior of a distribution center with some inventory policy. Then for a factory, you also describe how and when it should produce the actual product, whether it's make to stock, make to order policy, or any other kind. And Again, it may use a supplier to get some raw materials, and a supplier actually can be out of service for certain periods of time. For example, if employees are on strike. So when you finish describing your supply chain in such terms, you just play these rules, this behavior over time. So throughout our modeling time, you place an order for the first day as a customer, and 4 more days as well. On the fifth day, our DC, according to its own behavior, will understand that it needs to send an order to a factory to get some more product. Upon receiving this order, factory will start producing this specified number of product, order some raw materials, and for example, it may be not able to get it from the supplier because, well, there are strike on it. And when you execute such rules over time, you will get different outputs. Actually, anything you can measure in a real supply chain, you can measure in a dynamic simulation model, whether it's number of products placed, available inventory on any day through whole modeling time, number of items shipped, number of vehicles used, CO2 emission, and any other statistics. And with anyLogistix, we use this approach to calculate safety stock. But before that, just a quick overview of more advantages of dynamic simulation. Again, we do not need formulas. We just specify the behavior and rules, policies, like in a real supply chain. We play this behavior over time. We consider not like averages and deviations. We work with actual orders and shipments. We can capture any details, any personnel you need to keep your supply chain going, any fleet, any policy, any kind of schedules, and so on. And dynamic simulation model is very scalable. So for example, if you're expanding to a new market, you just need to add some more items with same behavior you already have. Now, inventory optimization. How do we do it in anyLogistix? Or actually in any simulation modeling tool? We have a inventory policy with a reordering point and reorder up to quantity. And for this policy, we also have an extra stock, which we'll use to find a stockouts from our usual inventory policy. So in ideal world, we never use this extra safety stock. But in reality, probably due to demand variability or supply time variability, we will need to use some amount of this stock. And we can calculate how much of this stock we need to provide a desired service level. So for 100% service level, we need this much. For a lower service level, we may need a lot less. Now, I hope you're not tired with theory, but anyway, we are going to see some of it in action. So here you can see our anyLogistix, an instrument for supply chain optimization for analytical and simulation modeling. And let's start with a very basic example, actually the same one we were considering when we were talking about like how demand affects safety stock. We'll create a simple scenario which contains only 3 pretty basic supply chain elements. So for example, let's go to France. And here in France, we have a distribution center in Paris, supplier somewhere else, and a customer. Now, as we said earlier, our customer has a very specific behavior. For every day, it orders 10 units of our product. So let's make it like this. Interval between orders just 1 day, and order size is 10 units. Well, we are done with the customer behavior actually. That's it. That's all you need to do. Now let's go to the sourcing policies. So all our customers are served from all sides, but actually we have only one here. So it will be this one. And let's also specify that our distribution center should be supplied from a supplier. Now we can see what's happening here with our supply chain. So the connections between customer, distribution center, and supplier. Then let's as well specify that our inventory policy for our site is an RQ policy with reordering point equal to 40 and the order size equal to 80. Of course, you can use any other policies available here. There are plenty. Now, also we need to specify the delivery routes. So at the moment, there is only one route between all locations, and we need to change that. So let's say that route from our site to our customer, the distance is calculated automatically. The costs are certain amount per product and per kilometer. And also we'll create another path here from a supplier to our site. For example, with a fixed delivery cost. And here we can manually specify that the transportation time should be 4 days. And let's make it not straight, but using real roads, which are supplied from our routing server. So that's actually it. Here you can see that we are using 10 tables in which we describe the behavior of our supply chain. The customer, distribution center, demand, inventory policy, locations of each object, path, periods, products, sourcing, and suppliers. Now, what we can do is we can run a simulation experiment. This experiment, we actually will see the execution of such rules in our model. Aside from this picture, we can also see certain statistics. So, for example, what I'm interested in right now is the service level. So let's see it as a line. Yeah. Here we see that, well, first our service level is dropping to 0, and then it goes back to 1. And it's pretty straightforward why it's like this, because for our inventory, we have no initial stock. Of course, we cannot work with the case like this. So let's put an initial stock equal to 80 and execute this experiment again. And now our supply chain is perfect. We have 100% service level, and our customer is happy. Now, let's see what happens if we will change our demand to be stochastics. I'll go back to the demand table and say that our quantity, not just 10 units per day, but a normally distributed value with the mean equal to 10 and deviation equal to 4. Just like this. Let's see what happens. We can see that our service level is dropping down. If we switch to a table, we can see the actual number. It's 85%, which, well, is not very good for us. Now, let's go to the safety stock estimation experiment. It's actually the way anyLogistix performs this safety stock optimization, where you can just specify how good you want your service level to be. For example, 98%. Then I'll change it to be less replications and less processors to use. So, for example, like this. If you are guessing why you need this number of replications, well, since we have a stochastics in our model, we need to run it several times to get all different cases. So when you're using stochastics within dynamic simulation model, you need to run that several times in order to get some meaningful result. Now, let's run this experiment. And very quickly, you can see the safety stock we need to provide 98% service level. Let's see what happened if we will want to get, for example, 95%. Just restart it once again. You may see that the values are actually quite low. So here, with 98% service level desired, we have something like 20 units safety stock, and for 3% lower service level, we need twice less safety stock, which is quite good. And if you compare it with the number we get while using the formula for safety stock, and the service level there was 95% exactly, you may see that it's quite close, but a bit less than 13.2. Now, let's check that it works. I will convert this result as a new scenario. And now I can run the simulation model again and see the dynamics. So let's get back to the line view. You may see the current service level, which is closer to the 100%. And as well, we may see our inventory dynamics. So you may see that for several days, we had certain cases of stockouts. Now, let's make this model even more complicated. Let's get back to the first one, and let's add a variability for a supply time. So it's 4 days at the moment. We will change it to the uniform distribution from 3 to 5 days, just like this. And now I will just run this safety stock estimation experiment with same parameters. You may see the amount of safety stock we need here, which is actually even less than we needed before. Let's convert it to the simulation as well and run it. So 96%, which is a bit above of our target of 95, but again, it is a common case when you have a stochastics, because, for example, for a different random seed which will change the behavior of a stochastic value, we may see a different picture. Or not. Now, we talked about the operational risks here, like what if our demand isn't fixed, what if our lead time isn't fixed, how our model will behave. But let's consider some different kinds of risks. For example, if our supplier can be unavailable at times. So for this, I want to create an event. We should change the state of our supplier from open to temporarily closed. I want it to occur at a random time through our model with a 100% probability. And let's say we have a different supplier somewhere else, which is a bit farther. And the transportation time from our second supplier to our site is, for example, 10 days. And also for a sourcing policy for our distribution center, we need to say that we want to use closest source through all availables, which are supplier and supplier 2. So if we will see this model, when everything is fine, our DC is supplied from a supplier 1, and if it is off, it will be supplied from a supplier 2. So let's run this model here. You may see that our first supplier got gray, which means it's offline, and we get our product from a more distant supplier, and our service level is horrible. It's about 60%. Of course, we need to change that. So I want to go and run this safety stock estimation experiment again. And here you may see how much safety stock we need if we want to cover the case when our supplier is offline. And even for 95% service level, we need to carry for about extra 60 units. You can also see a histogram of a safety stock, which we need through different replications. And you may select the perfect fit, like 75, or some to be somewhere in the middle. And actually, any kind of safety stock estimation experiment works like this in anyLogistix. You just describe your supply chain behavior using our predefined set of policies and demands, describe the connections between objects, and then just run the simulation experiment or a safety stock estimation experiment. Now, let's get back to our presentation and talk just a bit more about different cases. For example, multi-echelon inventory management. When our supply chain is a bit more complicated, when we have some between objects between a customer and a supplier, the problem is getting more complex. And we need to distribute our stocks between all echelons of supply chain. And while doing so, we need to consider the supply chain as a whole, not just like independent echelons with a separate demand forecasts and lead times, but all tied together. We also may want to observe the behavior of our supply chain and look for some undesirable behaviors like buoy effects, like overload of fleets, and so on. And also, we may want to consider a different replenishment strategies, not only our Q policy, but maybe min-max policy, production on demand, and so on. And in this case, while you are in anyLogistix, nothing really changes. You actually doing quite the same. So let's take a look. Here I have an example of a supply chain which contains several tiers or echelons. Yeah, I just used a simple Excel file to add this to anyLogistix. Let's overview the structure of supply chain. So we have here several suppliers, 5 to be precise, one factory, and a number of distribution centers. Each of them have a certain number of customers it needs to supply. And our demand is actually tied to the population of the city in which customer is located. So, for example, for Rome, we have quite big demand, and for Palermo, it's a bit less. And overall, we have here 100 customers across all Italy and 5 different products. And our inventory policies for our distribution centers are min-max policies, while for our factory, for finished good, we use on-demand policy, so it's basically make to order. And for the raw materials, we use min-max policy with both min and max equal to 0, which behaves same as order on demand. But it may use safety stock, while order on demand cannot. Now, our transportation times between the echelons is specified explicitly for the route from suppliers to a factory, which is from 1 to 3 days. And for other routes, from factory to DCs and from DCs to the customers, it's just calculated automatically based on the real road's distance. Well, we also have a sourcing policies which connects our customers, distribution centers, factory and suppliers, and also a production. And basically, a production is another source of stochastics in our model, because to produce one unit, we need from 3 to 7 seconds, which also may affect a supply chain behavior. Now, let's check how good our service level is at the moment. If I run this model, we may see here the inventory levels for different objects of our supply chain, for distribution centers for a factory. And we may see how actually bad our inventory policies right now, because our service level is about 60%. And we even can say for which DCs we have biggest problems. So, for example, for Terni and Florence, we have a 100% service level, while for some others we have it quite low. Now, let's run our safety stock estimation experiment with 95% desired service level, with 10 replications, and see what happens. So while this supply chain is a bit more complicated, it takes some more time in order to run it, but we are getting first results. Let's overview one single replication here, replication 1. We can see the desired stock for our raw materials at factory. And if we see this whole table, may see that for certain DCs we actually do not need safety stock at all. For another, we need just a few units, or a few hundred units, but it is not too big. And for others, we actually need a quite big safety stock here. So when we run through all of 10 replications, we'll get the histogram for our required safety stock here, and may use it to create a new scenario with desired parameters. Yeah, now. So here you can see the distribution for recommended safety stock here. You may see that well, for this particular DC is quite big, and for another DC is 100% zero. And if we convert this again to a simulation scenario and run it, we will see a quite different picture for our available inventory and for a service level. So the least service level across all our distribution center is about 95, and the biggest one is 100%. And if we want to see the single number, we can also do that. Yeah, and here it's 98%, which is bigger than we were expecting, but it is caused by these perfect distribution centers, which are actually do not need safety stock at all. So an average service level is 98, while the smallest service level provided by DC is for Rome, and it's 95%, exactly as we wanted. And if you want to consider some more information about your supply chain, you can go to our statistics list and overview, for example, the transportation cost and well, huge number of other statistics. So, as you have seen, the actual way to optimize your supply chain with dynamic simulation modeling is pretty straightforward and the same while you're considering a very simple supply chain or a pretty complicated one. And of course, with a bigger number of products with different supply chain structure, it always be the same. Just describe the behavior and run the dynamic simulation. But what if our supply chain behavior is more complex? If we have some more complicated policies, we have limited fleets, we have a certain customer behavior, we will be the same. And going ahead, yes, it will. And we'll consider this with the example of using material requirement planning policy in our supply chain model. And this policy used quite often because it's considering the forecast and optimizing the order size depending on our expectations. So, for example, if we're expecting big demand growth in future, we need to order more to fill our distribution center stock. So let's take a look at such model. Again, import the prepared example here. And this quite simple supply chain with one factory, two distribution centers, and a number of customers. And these two distribution centers are different with the inventory policy they are using. So for one customer DC, we have MRP policy with specified parameters here, which are actually the same as min-max policy parameters. So for example, minimum order quantity is 2,100 and safety stock is 300, just like here. But since the MRP policy is more complicated, it considers additional parameters like the days we want to look forward to calculate our demand forecast and to see how much product we actually may need. But let's see how it behaves right now. There are numbers of different statistics here. You may observe the costs, the revenue, profit, and so on, as well as available inventory on each side. But let's take a look at service level here. Let's go a bit in the future. You may see that for our distribution center with MRP policy, we have, well, not very bad, but not perfect result. It's about 85%. And for a distribution center with min-max policy, we have a horrible result with about 55% service level. We may check it for each customer individually, but well, I don't know if we want to do it right now. But what we want to do, we want to calculate how we may improve our service level. You may see here the recommendations about safety stock size for each DC, and it's quite big for our min-max policy and much less for our MRP policy. Let's check if it's working right now. Yeah, it seems like it is. So our service levels are pretty close, and if we will take a look at the actual numbers, you will see the 98 and 99%, which is above of our specified 98 goal. And if you want to consider another inventory policy or additional behavior like limited fleet, all you need to do in the anyLogistix, just describe it into our tables or use our extension mechanism to create your own policy and your own behavior. Of course, it's not the only way you may optimize your inventory policy in anyLogistix. Aside for the safety stock estimation, you may use a variation experiment to see the service level versus total costs with different reordering point size, or compare carrying costs and transportation costs with different batch size or quantity you are ordering from the supplier. You can overview the required number of product for basically each day of your modeling time and prepare your supply chain to behave accordingly, and much more. You can observe any metrics you actually can think about. You can capture all details, and you even can integrate anyLogistix into your business processes. So for example, for each day you may run a forecasted behavior of your supply chain and see if there are some potential problems within using digital twin idea or a control tower concept. So basically, that's it what we have for this webinar. And well, we're just a bit late. But anyway, if you want to know more about anyLogistix, about its capabilities, both analytical and dynamic simulation, please join us on any online or offline event. The closest ones are in Japan, Russia, and USA. Also, there will be another webinar on 28th of March, which will be dedicated to a transportation optimization. And you will receive an email where you can register for this webinar. And another thing I want to tell you before we go to the questions and answers is I want to ask you to fill our survey so we can understand what you would like to see on our upcoming webinars, which topics are interesting for you, which are not, and what we can do to improve our webinars as a whole, like more timing, less timing, more theory, more practice, and so on. So when you will finish with this webinar, you will be forwarded to our survey page, and just please fill the form there. So let's see if you have any questions. So it's a good time to type them. Okay. Is there a metric in anyLogistix to estimate lost sales due to unavailability of products? Yes, of course. Maybe I can even show it to you right now. Also, you can find all metrics available in anyLogistix on our website, where we have a full documentation about anyLogistix. And as well, you can get a free personal learning edition, which you can use to estimate how good it is for you, or you can ask for a fully functional free trial. So now, for the lost products, we have this metric called demand received dropped products, which calculated when order arrives to a distribution center and there is no stock and customer cannot wait, so like it doesn't allow back orders, you will calculate this. Sorry. How long did it take to develop the demo number 3 multi-echelon model? Well, for the demonstration purposes, it usually takes a couple hours, depending on like what you actually want to show. If we are talking about some kind of a real project, it depends mostly on the availability of data, because usually it's quite complicated to get your customer or your supply chain departments to share the information, which policies are used, how much it takes to deliver goods, and so on. But if all data is available and the size of supply chain is comparable with this one, like with hundreds of customers, several products, well, it still may take from a couple hours to a couple days. And well, for the more rare cases when there is more complicated supply chain, more complicated policies, well, maybe, I don't know, a week or two. Again, it depending on your experience with anyLogistix. So I suggest you to finish our training course before you will try to build such models by yourself. Next question. What is done by an expert? If so, how much longer would an analyze take on average? Well, all of it was done by me, and well, I'm a developer of anyLogistix. I'm a programmer, but I'm no supply chain expert. So, well, of course, I'm not an analyze, but if you participate in our training course, you will be more or less prepared to just create such models with no problems. And even more, because our training course is very vast and covers all anyLogistix capabilities, starting from greenfield analysis experiment up to creating your own inventory policies, sourcing policies, and your own customer and DC behavior. Okay, so more questions. From my experience, what's maximum number of product locations that we can optimize with anyLogistix? Well, it mostly depends on how good your machine are, because for a simple laptop I'm using right now with only, if I'm not mistaken, 8 gigabytes of RAM and uh, very basic CPU, I'd say that the limit is, well, about several, yeah, I think several thousand of customers and tenth or maybe up to 100 products. But on my workstation, I can raise this number by a lot. And if you have an access to a good server with lots of RAM with a strong processor, well, it's I'd say that in the real projects which uh, was done with anyLogistix, the projects with thousands of customers and thousands of products were made with no actual problems. In the sense of a digital twin, in which way is it possible to import current data from the ERP system to anyLogistix? Well, right now we have two built-in options. First one is an integration with an Excel file. So you can just import your data into an Excel file with a specific structure and then uh, use it in anyLogistix. And as well, you can create the preprocessor. It's basically a number of operations which should be done prior to experiment run. So you can create here a connection to your database of your ERP system and download all the new data like demand or new customers or current place of all vehicles and so on, and run this experiment over an updated data. And right now we're working on some other ways to integrate anyLogistix within business processes, including uh, headless run. So you actually may even not open the anyLogistix itself. You can just build in your process the run of simulation experiment, and you will get a report from the anyLogistix if something is wrong in the future according to a simulation modeling. If you want to know more about this matter, or if you actually have more questions, want more detailed answers, please contact our support team through form on our website, and you'll get all the answers you need. How can I calculate CDF for inventory distributions in safety stock experiment? Well, it's actually presented on the experiment itself. Here, so you may see the histogram bars with the occurrence numbers and CDF as well here. And another option you may use here is to export all statistics from the experiment to an Excel and then manipulate with raw data the way you want to. Can we undertake simulations on customer arrivals and service applications using AnyLogistix software? Now, if I understood this question correctly, it's a pretty good one. And please make it clear if I'm wrong here. But as far as I understood, you want to create your own behavior for customers, and you can do this by using anyLogistix extension editor, which is supplied along with anyLogistix in anyLogistix Studio Edition. And here you can create your own customer model. It have to follow a certain rules about this, well, what should be presented there. But anyway, it will be your own model, which you will create by using anyLogistix, well, anyLogistix-like tool, and the behavior will be the one you described. Can you buy this tool and integrate to any ERP system? Actually, yeah, you can do that. You will require some additional efforts creating these preprocessors if you want to like make it automatically, but it is doable, yes. Our submodels are able to be linked together. Yes, actually, what you are doing with the extension editor, you create your own model of customer, distribution center, factory, supplier, or even several kinds. And then back in anyLogistix, you can specify that your customer could be not just a usual customer, but your extended customer. And one of your DCs could be DC with staff and so on. And again, you can also override your inventory policies, sourcing policies, transportation cost calculation policies, and so on. Is it possible to see how statisticals measure changes if the value in a physical location is modified? Yes, of course, but you will have to run this simulation modeling twice, or use our variation experiment. I can create just a quick example here. So, for example, if I want to change the location of the factory, I can move it around. Well, if you want to use latitude and longitude, you can specify them explicitly, or you can say that you want to modify the actual location of a factory through number of available locations here. You can move it to Chicago, Houston, or whatsoever. And for each location from the available option, you will see number of outputs, and you can easily compare them on the same chart. The optimization of the respective shown supply chains were done manually by the user based on his experience. Either also an automatic and prescriptive optimization add-on? Well, good question. I'll try to answer shortly because we a bit out of time here. What we have here in anyLogistix is some instruments to create and optimize supply chain, of course. So, for example, greenfield analysis experiment, which allows you from the number of customers and specified demand, suggest a number of locations for example, 10 distribution centers. You may see here that if you have 100 customers throughout whole world, you need to place your 10 DCs like this. Another optimization possibility is network optimization experiment. So I'll show you some examples. For example, here we have a number of options for our distribution centers, again, across the whole world. And using this network optimization experiment, you can find the optimal number and the locations for distribution centers, the optimal policy parameters for your customers, and so on. And a number of other optimization capabilities like transportation optimization, different simulation-based experiments, and other. So I think that's it for the questions. If I accidentally missed your question, please don't hesitate to contact our support team. It answers within 24 hours usually, so our service level is quite good. And again, participate in our upcoming webinars, go to our offline events. It's usually a lot of fun and a lot of useful information there. And I want to say thank you again for participating here. My name is Dmitry Rubel with anyLogistix development team. See ya.